All right. So in today's class, we'll again deep dive into some of the Spark internals and try to understand how exactly it works and what are the different high-level components, right? And to basically to know more about Spark, and also we'll discuss in detail about the some of the concepts when we work with Azure Data Bricks. Okay, so what is Spark? Right, I know somewhere you would have read and or know about this word Spark, right? So Spark is basically is a distributed data processing engine, right? It's a fast unified analytics engine for a big data and machine learning, right? So guys, we need to understand one thing here. So what is machine learning? Okay, so machines where we input the data so that the machines learn from the data trends and patterns, and accordingly, and it will recommend something, right? And simple example could be it's artificial intelligence you are inputting. Okay, so now as AI and artificial intelligence is evolving more and more, and it's very important. The data is going to be play backbone of AI, any AI work, right? Without data, nothing works. For example, you would have had the recent innovations in Chat GPT and all. So there is a huge among us data being processed and trying to train those models. Okay, so that's where it's a need to process the data with fast and in a distributed manner, so that the businesses can take an advantage of those patterns and identify the risks, and then they can plan accordingly. Okay, so now before Spark, as we do have a big data engines, right? um, but they have some some kind of a constraints, and there are some kind of a limitations where we will not able to process fast, right? Now if you see, if you type something in Google search, right, let's say you type something, and within the fraction of seconds you will get the result. How do you think how it's possible? How is Google processing that information that much fast, right? There are hundreds and thousands of um, clusters being deployed behind the scene, and then they work day in day out to process the data, and gives you as an output within the fraction of seconds. The same thing, if you type something and it takes an hour to process, it's not useful. Nobody likes that, right? So that is where we need a fast unified analytics engine to process big data. Similarly, the same thing, big data. I got a sales data from my source. I wanted to know immediately those numbers. I can't wait for a hours and days to process the data and then get the report and all. Right? So it's a fastening world. Okay, so that's where Spark going to play major role in this big data processing with a fast, and many of um, you would have in the real time use cases, you would have seen that there is a Spark engine behind the scenes runs and process the huge amounts of data. Okay, so how it process that? As I said, it's a distributed data processing. So what is distributed? Right, for example, you are a team lead, there are the 5 people under you, and there is a work came to you. So what do you do? Being a team leader, you split that work across those 5 people, and everyone does their piece, and they will update you, and then you will consolidate and give to the management what are they have given to you, right? Similarly, when it comes to the distributed data processing, um, you'd be dealing with hundreds of GBs of data, and sometimes it's terabytes and petabytes of data. right? So those data are going to be splitted into multiple chunks, and they work parallelly they work parallelly across the multiple resources, and then process the data. Okay, as I said, it can handle up to petabytes of data. Okay, with thousands of physical and virtual machines. All right. So now why Spark? I think we covered a bit. So because we wanted to query speed, we want to speed data querying and analysis and transformations with large data sets at scale. Right? There is no compromise on that. We need the speed at scale, and that's where the information lies, and that can be help the businesses. As I said, right, if I get a sales data, and if you take say hours and days to process the data, and I came to know the top products only after a week, there is no use of data. I want to know what is happening right now. I want to know what is trending right now in my Twitter page, right? So that fast we need. All right, and then Spark definitely helps in this even reading and writing the data from multiple sources and processing using a multi-thread tasks, and also it uses the JVM to process the data, and also it has an in-memory capabilities to process the data in memory itself to fasten the query processing. Okay. Now another advantage is of the Spark is it has a rich API support, so you can use any APIs that are available in Java, Scala, Python, or R, right? So you can use those APIs and to work with Spark. You need not know exactly how the Scala works, how Java program works. You need not know, but all you need to know is you need to just know the APIs to be called, right? And also uh, it's a super fast, especially for interactive queries, right? As I said, I got a sales data. I want to query the data and get to know the details within the fraction of seconds. I can't wait for any more to process the data, right? So Spark is very good in that. And also, as I said, it supports multiple languages and integration with other very popular products. Okay, I'll give you a good example. Okay, so let me move on. I will give you good example so that you can think of the powerful how powerful is Spark engine. Okay, so now to make it a more clear in terms of benefits, it's a speed. Of course, it's a speed, and it has a powerful caching mechanism to process the large data sets in memory, and it has easy deployment options, and it's a real time, right? Now, can you tell me a real time scenario? I will give you a hint. Okay. Um, but before that, let me so it's polyglot, so it supports multiple languages and it's a scalable, right? So it's yeah, whether you can process 1 GB of data, you can process 100 GBs of data, you can process 1 TB of data, or you can process 100 petabytes of data, right? So it scales automatically, scales in and scales out. Okay, so now when it comes to real time, let me give an example. So I now it's IPL season, right? Hope everybody is watching IPL in the Geo Cinema, right? So what do you think? How Geo Cinema, the app is doing the real time analytics of a real time streaming of the data from the match, and it's coming to you. How it's possible? What is the technology behind the scenes? The same Spark, right? Any OTT platform you take, for example, G5 also broadcasting some of the matches, right? And you would have seen in a day 1 crore, 2 crores people are watching live. So how it is possible? The same with the help of Spark engine. So that's powerful. It is okay. So if you want to know more about how the real-time streaming works and all, go back and read those blogs where they are leveraging Spark and the clusters in a way that that you can achieve a real-time analytics and real-time streaming of data. All right. So that's the homework for you guys. Okay, so now the ecosystem we already touched upon yesterday. So it has a huge ecosystem of to process structured, unstructured, streaming, machine learning, as well as the complicated graph as well, right? So it covers all the spectrum of use cases when it comes to the big data processing, and it's supported by the core APIs available in all the four languages, which are Java, Scala, Python, and R. Okay, so Spark originally written in Scala, which is Scala again. It is a Scala and Java are almost identical. Okay, but since the growing Python is growing, and it also Python supports the Python and R. All right. So some of the common use cases we touched upon high level yesterday, but I was giving an example of Geo's Cinema and G5, right? So using streaming data, you can see the streaming data. So this is what it is. It's processing streaming kind of a processing real time data. This is where the some of the most use cases of Spark, right? Of course, it supports normal ETL batch jobs, but the powerful you came to know when you do the streaming using the Spark, right? And example I already gave you Geo Cinema and G5 OTT platforms. Go back and read their blogs how they are leveraging Spark. Okay, so quick on architecture side. So as I said, it's a distributed data processing engine. Okay, so you have a driver program in the name of Spark context, which basically opens up the process engine, and when you give give a task to the when you create a Spark context and create a task to complete, and there is a cluster manager which actually manages the different worker nodes, right? So this example is very typical where we have a two worker nodes only, but in real time there could be thousands of worker nodes working day in day out. As I mentioned, Google, Yahoo, Finance, right? They have a huge data centers, and there are thousands of millions of worker nodes are working day in day out. And if you type something in the Google search, the within milliseconds the result is coming is because of these all the worker nodes. So what happens when you type something, the request goes to Spark context, which is a driver program, and it automatically initiates the talk to cluster, and it diverts the task, and it will assign those tasks to different worker nodes, and the worker nodes executes the tasks, and they will give back to cluster manager, and that's how you are getting the information back to your browser. So this is the end-to-end life cycle, right? So now with the information is coming in within milliseconds, you can imagine how fast it is, and with the fraction of seconds how fast it processes the data and gives back to you. Okay, so this is the typical architecture where as I said, right, you have a driver program, you have a cluster manager to manage the clusters. So this cluster basically is manage, he knows how many worker nodes are available at this point, and then he can assign those tasks. And then it could be possible also one worker node is down, right? So you will have a only one or two, right? So accordingly cluster manager takes care of those assigning that work to some other node unless until this fixed. And within the worker node, you can see there is an executor program got installed, and underneath there is a cache mechanism, right? So as we said, Spark process the in-memory data, right? So it uses this cache memory to process the data within the work node, and then accordingly the it's going to be faster processing. Okay, so that's the powerful of distributed processing. When I say distributed, the work is distributed across the uh, different worker nodes, and then there is a cluster manager who takes care of managing all the nodes, and then accordingly your job, the task, what are the job you are asked to perform, it does that. Okay, so this is very important concept for you to remember. So whatever you do in the data bricks, it's going to be a Spark program in the underneath, right? So that's where you see Spark jobs everywhere, right? Why? Because of this, uh, the underneath there is a job going to be executed and gives you the result. It's very simple. Okay, so any questions so far? All right, so let's move on. Now, when you work with Azure Data Bricks, some of the concepts you should be aware, right? Because it's a new one, and it's a different one. Okay, so the first one comes to picture is workspace. So what is workspace? Workspace is basically an environment for accessing all your data assets, right? So what are your data assets? So you might be working with some marketing project, you might be working with finance project, you might be working with some other department, right? So to accomplish those works, to accomplish those projects, you might be creating multiple notebooks, some creating some libraries, creating some dashboards, etc., etc., right? So all those related to the particular department what you are doing can be bundled into one workspace, and then accessed accordingly, right? That is what called workspace. It's like basically organizing your work, right? So in the day in day out you might be dealing with notebooks, libraries, dashboards, experiments, all you need to be dealing with. But if you club everything into together, like marketing, finance, everything you club in one together, it's very difficult to manage. So this workspace help you to uh, um, manage the work in a logical way, so that it's not confusing, and it's very easy for you to carry out your day in day out work. Okay, so now if you quickly see, so as you can see, this is a workspace, right? So under workspace, right? So you can see users. So by default, so you can create shared workspace as well as a user specific workspace. Shared workspace is nothing but the workspace can be shared with your other team members, right? For example, in the marketing domain, you might be working in some tasks, and there is another team member also working on the same thing, right? So we don't want to work you on your way and he on his own way. The silos, it will create a lot of silos, and it's a very problematic, and it's a time consuming when you integrate at the end, right? So in that case, you can share with others, right? If you have anything, you can create a share under shared, and that can be shared with your fellow team members, right? But second one is user specific. Okay, I don't want to share with anybody. It's a isolated piece of work. So I want to keep on my own. So you can under your users. So there will be user ID, and the user under user ID you can create the notebook, library, anything that you want. Okay. For example, if you see under me, I have created on my own finance, marketing, and there are some other stuff. Right, so all finance related work I can create notebook and I can keep it over here. And all any libraries that I wanted to, third party library I want for this finance project, I can install it over there. Right, I can create multiple folders, or I can do some experimentation with the data. I can do some workflow, ML flow, machine learning tasks and all. So all the stuff I can bundle together that belong to finance. Similarly, that belong to marketing, right? So this is the easiest way of managing things. Otherwise, if you club everything and there are hundreds of notebooks are available, and libraries and everything is available, and you don't know which one is for what, and it's at the end of the day, it's create more confusion than um, it will become a difficult to manage those stuff. So it's very easy if you segregate and depending on the work, depending on the use case, depending on the work, depending on the situation what you are into, you can logically divide that work accordingly so that it's easy to manage in the future. Okay. So now within that work, let's say you are working in both the you're in both the projects, right? So for example, finance little complicated, so you don't want to uh, uh, you want to have an access control over that, right? So those kind of stuff you can manage with the access control list. So you can you can attach a access control list to a workspace, cluster, job, everything, so that according to the list, only the users who have access to that can be access those notebooks. No other guy can touch that, right? For example, let's say I'm creating a notebook. This is related to finance, so I don't want anybody to look into access this one, or I don't want anybody to look the logic behind what I am doing. I want to have a restricted access. Okay, so what I can do is I can control that access using the access list. Okay, so now the next one is notebook, right? So this is a very common term when you're working with the Azure Data Bricks. Without notebook, nothing works. Okay, and notebook is very intuitive web-based interface where you can run commands and visualization and etc. Okay, so now if you go to, for example, this notebook, see, I don't have anything as at this point, but I can create multiple commands, and I can club together all the commands, and I can run across as part of this notebook. Right? It's basically dividing your work in a multiple steps and then executing them together. For example, when the sales data comes, you might be adding some new columns, you might be aggregating the data, or you might be removing some data, you might be running some transformations, right? So those all can be running with multiple commands, and they can run one after another in a logical manner to achieve the object. Okay, so that's where you can see it's a very intuitive way. You can just with a few clicks you can work on that. Okay, library is another package of code that we if at all require. Okay, if let's say you're working on a client had some third party libraries that wanted to use it, or you're working in a project that's very custom libraries that your organization is managing that you want to use it, right? So in those cases you can install those libraries for that in the for the workspace, right? Otherwise, 90 to 95%, even 100% of times, Databricks provides all the libraries that you require in day in day out. You don't need to install any specialized libraries for your normal work, unless it's a requirement from client or any third parties. You have a specific to your organization as a specific to use. This installing library will not come into picture. All right. So now understand some more Databricks file system. That's right. What is that file system? It basically contains the directories which can contain files within the Databricks file management system. Okay, so it's basically a block kind of a blob storage, if you ask me. Okay, blob. Now, if you see under data, you can upload files and all. Right. For example, see, you can upload a file. Now, when you create a workspace, when you log in, automatically the Databricks file system will give you a path. For example, in this case, file store, under that there are tables. Okay, under that I can create my own tables. Okay, this is going to be your target directory. Okay, so you can upload a file, you can drag and drop any file, and then you can work on that. Okay, which we are going to discuss in detail in further classes. All right, it also gives you data get from the Amazon. For example, Amazon S3. It's a storage service from Amazon. You want to pull the data from Amazon S3, you can do that as well, right? And there are other pre-built sources that you might be working with day in day out. For example, Amazon Kinesis, Cassandra, Snowflake, or any JDBC, Kafka, Relish, any type of these sources you want to pull the data to Databricks, and you can do the further analysis. You can do that. You can use these connectors, and automatically these connectors connect to respective sources and then pulls the data. Okay, and that's how this importance of DBFS. Okay, so in other words, DBFS is nothing but your home path, right? Whatever you do the files uploading and you play with the files, they're all available in your home path, which is a file store slash tables. Now, once you have a file, we can create your own database also, right? And database, what is database? We already discussed. It's a um, collection of objects for tables, views, functions, whatever you want to do that, right? So, for example, if you see, once you do that, and you can see, you can create your own database here, right? As mentioned in the same example, for example, you are dealing with the sales data, right? So you can create a database for all the sales related data that you're dealing with, which will logically make sense, and you can create a model out of that, and you can access from here. Similarly, marketing data, similarly, finance data, right? You can create multiple databases, and underneath you can have those tables, views, and everything that can logically make sense, and you can work on those. Okay, so either you can create your own database, or you can connect to the any existing data also. Like for example, let's say uh, your organization using a SQL database, and you want to pull some of the data from there, and you want to some process the data and again send back to SQL database. So you can configure SQL database also here, or any other database that matters. Okay, so now metastore is its internal structure. Okay, whenever you create a whenever you create a file or anything, it automatically captures all the relevant information about data of the files. For example, column names, column types, and partitions, and who has created, when it was created, all the meta information it captures automatically in the form of metastore. Okay. So now the next one is cluster. Okay, so what is cluster? A set of computation resources and configuration to run the notebooks and jobs, right? So now I created a notebook and I wanted to run it, right? To run it, I need a compute. I need a storage and compute to do that, right? Without that, nothing works. Okay, so now go back and see there is one test being available cluster, but you can create a more also. Okay, so for example, I want to create another report. You can see, you can choose the runtime if you want, otherwise leave the default one. Okay. And as we discussed, it's a 15 GB memory is what given to community edition. Okay. And you see there are 0 workers and 1 driver. Now, if you go back and relate to the diagram we discussed, see with community edition, we are going to get the 15 GB with a driver program. We are not going to get any worker nodes. That means our data, what are we going to do using community edition, cannot be processed in a distributed manner, which means you cannot process a huge amount of data using this community edition. If you can, but it takes a lot of time. Okay, but the basic of community edition to learn yourself, irrespective of the volume. You need to do some hands-on. You need to learn the concepts and you need to practice that. Okay, so that's why it gives you 0 workers. You see that there are no workers being allocated given to us. Okay, it's all in other words, if you ask me, the same server and the nodes, everything got installed into one machine only, and which has the 15 GB of memory with 2 core processes. So, see, okay, and if you want to higher purposes, you want to hire one, you can go back and purchase um, higher configuration machines. Okay, so for example, if you see the pricing, so there are a couple of options. Pay as you go model, right? So that means there are no upfront costs. So only pay the amount of time you are going to use the cluster. Okay, and you can use the committed use discounts, so you can take advantage of that, right? And these are the costings. If you see, if you are doing any streaming data, it's going to cost 0.05 per dbu. dbu is nothing but database unit, which is internal for data bricks. And when you do something, it automatically calculates how many dbus are required, and you're going to pay those many dbus in terms of dollars, right? If you're doing a delta table, you have to, there are different. And if you're doing SQL, it's again another cost, right? And you can see all purpose compute, if you use, is going to cost 40 cents. And serverless, some of the thing it costs less, right? So you, based on the need, based on your workload, based on the uh, commitment you have, you can take advantage of all these uh, pricing options, and accordingly you can set it up. But since we are doing here, we don't have any choice. All right. So now you can see, if I try to create another cluster, it says that I already reached the maximum number of active clusters. So that means only one cluster is allowed to use it in as part of community edition. Okay, so which I already have one, which is fine. Okay, so that's about clusters. And Databricks runtime, we know, so it's internal and it's already managed by the Databricks itself. We need not break much into runtime. It gives you every feature comes with every different runtimes, and if you're any specific for specific use cases you want to use the specific runtime, you can choose it and associate the cluster. Otherwise, the default one, whatever is a stable runtime, is you can use those. Okay? And then finally, workflows. So workflows is nothing but creating a pipelines. Similarly, what we created the pipeline with different activities and with different transformation, we have created a pipeline in Azure Data Factory. Similarly, you can also create a pipelines with the different notebooks. For example, let's say you have a notebook and you want to call it in another notebook, and there are some dependencies. All the stuff you can bundle into a pipeline and you can create a workflow. Okay. So cluster types, I think we discussed. So there is standard cluster and high concurrent clusters and single node cluster. All right. So single node cluster is what is we are using in for our community edition. But if the required, you can use high concurrent clusters. It's a very high power machines where to process the huge data you can take those. Otherwise, standards, which is a normal use cases, you can take use of that. Okay, but each one costs you accordingly. The cost is different for each of these cluster types. Okay, now some of the guidelines. So when you create a cluster, so you cannot change the mode. You cannot create a standard and then you want to create a you want to change to high concurrent. It's not possible. Or the other way, let's say you created a high one and you want to go back to standard. It's not possible. Okay, the only thing possible is you can create a new cluster. That's it, and delete the existing one. Okay, since the pay as you go model, so by default, standard one 120 minutes by
Hello, sir.
default. Yeah,
Hello.
can you hear
Network
me?
issue, I think so. Your voice is breaking, sir.
Okay, so what I'm saying is, if you want to change to the cluster types, you can't change it once cluster is created. Okay, the only option is available is you can create a new cluster and then delete the existing cluster. And standard and single cluster you can configure by default. After 120 minutes it can go uh, automatically, they can be terminated. Okay, and whenever you want to do you need a cluster again, you can recreate again. It just takes a few clicks to create a cluster. It's not more than that, right? But high concurrent ones, it will not terminate automatically. You need to manage manually according to your use case and according to your need. Okay, so now let's quickly go to uh, workspace and see. Okay, so this is my notebook and you can see by default Python, but I can change back to SQL, Scala or anything, right? That the settings I can change on myself. Okay, so one of the beauty of I wanted to touch is the help, right? So Databricks gives you, yeah, so Databricks gives you very good documentation. You see, since we are using Python, welcome to Python help utility. So, and you can type it over here if you have any questions. For example, you wanted to know keywords, right? So let's type keywords. So all the keywords will come to you. Let's say you wanted to know uh, else if, right? So you wanted to know how else if works. Okay, now you type else if. Now you see it gives you automatically what how the if statement is used to conditional execution, and you can this way you can declare a if statement in your notebook. If assignment expression true, else if assignment expression true, else what it needs to. Right. So you can see the documentation is very, very beautiful document. Any third class guy can easily understand. Right. That's where I keep telling you that you if you know already, if you're hands-on with Python or anything, it's good. Right. I'm not denying that, but if you even if you're not also, you can easily use this help and you can take these helper functions and all, you can practice yourself. Okay. Now if you see here also, I think somewhere we saw that. uh, so you can see here help, right? You can see help center and documentation, knowledge base, all the access you have. Okay, for example, you want to go to documentation, you see all the documentation you have access to. Okay, and the similar way you going to go and see the knowledge base, right? So this is the knowledge base, you can type anything and you can get the answer. You see, it's kind of a Google for Databricks, right? So you can take off these all these resources which are available freely for you to access and work on this, right? Even though even though even though you don't have any prior experience, but still you can learn and you take off these freely available resources and you can practice on your own. Okay, so that's one thing. Second thing I just wanted to tell you is, uh, uh, so from tomorrow will be working on full-fledged with the notebooks and all. Okay, um, so the foundational building blocks in terms of what is Azure Data Bricks and what are the use cases and what are the scenarios, and within that Azure Data Bricks we also touched upon today to understand more Spark. Basically, what is Spark? Why is there is a lot of buzz with Spark, right? What special it is? What are the different use cases, and what are the different benefits? We discussed about that and how the internal architecture of Spark, how it works with the distributed data processing, right? So we know all the stuff now. Now let's go back to, now it's time to do some hands-on using the notebooks, right? Upload some data, create some database, and play with the data, do some transformations, right? So all those stuff you're going to do it from tomorrow. Okay. So my request to all of you is, if you want to um, uh, go back and watch the video, yesterday's one and today's one again, go back and watch and be familiar with the concepts. If you're not clear on the concepts, no matter how it is, it's always a day one for you. Okay, be familiar with those concepts, those jargons, those words, remember those, and from tomorrow onwards we're going to do the full-fledged exercises. All right, guys. Okay, so anything, any questions or anything? Somebody has asked how many days I will happen to learn. Can you repeat, Raj? I didn't understand this question.
Hello.
Yeah,
Yes, sir. So how many days it will be go? So how many days we have myself to learn the data bricks?
yeah, it will be around 20 days.
14 days, sir.
20 days.
20 days. Okay, okay. So for the interview purpose, you can learn, right?
Yeah.
Okay. So, for this, Python is mandatory or what, sir?
See, as I said, right, nothing is
Okay,
mandatory. It's
okay,
all you can learn on the job. You can learn on the as I just gave you example of help documents and all, right? So we
okay,
have
okay,
a huge uh, knowledge base is available. You can take advantage of those, and then you
okay,
can now work, learn on the fly as well.
okay.
So, I see, Michael, you are there. So, do you have any prior experience with any object-oriented programming languages, Michael?
Well, I took a Python course with online training.
Awesome, awesome. Yeah, yeah. So that if you already learn the Python, it's going to be take you to the next level with PySpark. Yeah, but some of you new to programming languages and all, so spend some time to learn the basics, because see, we definitely so nothing is mandatory, but that doesn't mean that um, we don't know anything, right? There is a difference between knowing and doing, right? So at least spend some time to know how some of the concepts, right? And those across it is similar across all the languages. Okay, so that's the uh, um, one thing I wanted to stress upon. Okay, and second thing is from tomorrow we will be doing some hands-on with the notebooks, right? So we'll starting with SQL, and then we'll eventually move to PySpark with the Python libraries. How we can move to we can take care of PySpark, and what are the some of the benefits, and the API, the rich APIs available with the Python is humongous, right? I haven't seen any in my career. I haven't seen any the APIs support available in a language, right? So that is where PySpark is growing up, right? Everybody is using, and everybody it's kind of a stamp, right? So I need not go back and see whether this works or not, right? It works across the industry. Okay, so we'll be starting with SQL, and then again moving to our original subject, which is a PySpark, and we'll be learning different data frames, RDDs, right? So these are the new words, might be new words to you, but eventually you will get used to that, and that will become a normal. Okay, so that's what we are trying to make you more in terms of how in a real time you can work when a situation comes to use the data bricks or the area for anything, how you can think through and how you can work with the real time use cases, uh, and you can choose the right option to do the right work. Okay, so that's about today's stuff. And tomorrow, as I said again, from tomorrow we're going to rock with the different um, notebooks and with the sequel. And yeah, so that's the agenda, guys. So now, any questions from the data bricks or the data factory that you might have, we can discuss. I hope you found the examples and the real-time scenarios that we did in Azure Data Factory, and you're able to catch it up. Some of you have done, some of you are, still doing. And if you have any questions over there, we can discuss there. Yeah. So last 5 minutes, we can use it for questions. No questions, all clear? Come on, anything. I mean, there is no question is right or wrong. If you have a question, that's the question. That's it.
Sir, what do you mean by synapse analytics, sir?
So that's again another package from Microsoft. It's basically an offering, right? So I think as part of this course, we are touching upon Synapse as well, high level. So basically, as you can see, you have ADF one side and you have a Databricks another side, and in between there are some other stuff, right? So when you think of a real-time project, it's very difficult to manage some of the stuff here, some of the stuff there, some of the stuff in different place, right? So Synapse is again combining all these things into one, bringing everything into one umbrella. Okay, so there you can do pipeline, you can create a pipeline, you can do write transformations, you can write PySpark, you can do it, this, that, everything in one umbrella. You need not go back multiple things. Okay, and that's the basically it's a commercial aspect from Microsoft to um, to take advantage of this mm, Spark, right? So far, if you see, I mean, if you are a real a businessman, now if you see Databricks, I'm using it from Microsoft portal. That means Databricks and Microsoft are two different companies. Okay, so now whatever I'm paying, I'm using Databricks. Let's say I'm paying $100 every month to Databricks. Now the underneath infrastructure, right? The work nodes, and the everything that is given by Microsoft, the VMs, right? Databricks doesn't have any cloud or anything. So what Databricks is doing, Databricks is the Spark engine, which is commercializing using the other aspect of Microsoft. So if I'm paying $100 to Databricks, obviously some 25 to 30% goes to Microsoft. Why? Because Microsoft is given the platform for the Databricks to work. Now, if you understand the commercial aspect of that, now Microsoft, why don't Microsoft can do this alone? Why Microsoft has to partner with Databricks? Right? So that is what Synapse. All right. So in Synapse, you don't need a Databricks. Right? Microsoft also has their own Spark engine. Okay, so it's all, the as I keep telling, the foundation remains same, but the flowers, different floors have different buildings we can build on top of that. Okay, we'll cover in the high level Synapse as well.
Thank you, sir.
Yeah.
Jupyter Notebook and Databricks Notebook has the same functionality, or is it different?
Absolutely the same functionality. So Jupyter, you had to manage your own, right? It's a open source one, and you had to handle the patchings, upgrades, and all. You had to manage your own. Whereas a Databricks Notebook, you need not do anything. It's completely and fully managed by Databricks. For example, libraries and runtimes, everything completely managed by Databricks. Whereas if you are using a Jupyter, you have to manage on your own. Does that answers, Michael?
Yes.
All right. All right, guys. I think we are on top of the hour. Okay, and we'll catch you tomorrow with more hands-on. And believe me, this Azure Data Bricks going to be more fun, and you every day is going to be new day, and you learn more. Okay. See you guys tomorrow.